Today we're working on the 2001 Buick Sabre. We're doing the oxygen sensor lab. As you can see, way down there, right there, we do have our oxygen sensor. And currently we are tapped in to both of the sensor signal wires. And we are initially testing resistance between them. We're getting about 4.7 volts. Which according to specification, like generic specifications, being between 3 and 30 ohms, I would say that just about 5 ohms would be within specification for that.
Alright, so we're working on the Buick Sabre for the oxygen sensor lab here, and right now we are working with a 4-wire O2 sensor right back here. You can see her right there. I got the diagram and connector views pulled up right here, so you can see that the tan wire is going to be our sensor signal low, and then we also have our purple wire, which is going to be our sensor signal as well, and then the black and white wire right back there is going to be our ground, and then the pink is our fused output.
Alright, so we currently have the vehicle warming up. We have it on. As you can see, for air-fuel ratio, it is just reading like a flat 14.7. That's gonna be because it is in closed loop, so it's not actually using the oxygen sensors right now. So we will come back and we will check the readings off of the O2 sensors once the vehicle has warmed up and reached open loop. All right, so now we have our vehicle warmed up. We just have the scan tool paused for a second. You can see we have reached open loop and we are getting an AFR reading. And then as you can see, once we hit that open loop, the vehicle started relying on the O2 sensors for information. So as you can see, it is a little shaky in the beginning while it was in closed loop, because before it was warmed up, it didn't really know what was going on. And now that it is warmed up, it can get a little bit more accurate information to read.
All right, so now we're looking at our fuel trim right now, and you can see as Bailey's revving it, it's heading about 15%. It is staying a little high too at idle as well because it is misfiring like crazy, but based off that, the readings, it is staying within our average 5% range. Just with our misfire, it reads a little higher. Then you can go ahead and rev it and show the difference. And you can see there, bumps up right here. Alright, me and Bailey are back here on the Hyundai Tucson, and we're doing our wideband oxygen sensor test, and you can see our actual lambda values right here. We could not find our fuel trim, but it would make it a little bit easier. You can see our estimate of what we should be in right here, and I can give it gas too. You can see it move. And then we can show you underneath where it is. What? It's gonna be our pigtail, and then it's going to be going all the way back down here, and then our last sensor is way back down there, but we're not with it right now.
Also, with the wideband O2 sensor, just as a test, we did try measuring it. We did try measuring voltage at the connector with the DVOM, and we were finding that pretty much all the there was one pin that was 12 volt, and then all the rest of them were sitting about 2.3 volts, which just does kind of go to show that you can't really use you can really only use the scan tool to test the wideband sensors.
Alright, so here we're going to be looking at the connector view of our narrowband O2 sensor for our 2000 Buick Sabre 3.8 liter. As you can see, it is a 4-wire sensor, narrowband. For our pin A, it's going to be a tan color wire. It's going to be our heated oxygen sensor low, and for pin B, we're going to have a purple wire. It's going to be our heated oxygen sensor signal, and then our pin C, black with white tracer, is also going to be our ground, and then our pin D, pink, is going to be the fused output. This sensor starts working after 662 degrees Fahrenheit, and it reads a signal of about 0 to 1 volt, which you saw earlier on in the video. 1 volt, you're going to be reading a little bit more rich, and then closer to 0 volt, it's going to be a little bit leaner of a ratio. These sensors are usually 4 wires, and the PCM does supply 0.45 volts, And the voltage can be measured on a scan tool or by measuring it at the connector.
All right, now we're gonna go ahead and take a look at the O2 sensors from our Hyundai Tucson. As you can see, we have two different sensors. One is gonna be a 6-wire, one is going to be a 4-wire. That is because the upstream sensor before the CAT is going to be our wideband. That is going to be the 6-wire, which they are usually 6 wires. And then our secondary O2 is going to be post-CAT. That would be our downstream, which is usually a narrowband. With the wideband sensors, they typically work around 1200 degrees Fahrenheit, just to help with emissions. Like I said, they are usually 6 wires, and they can actually only be measured, they can only be measured using a scan tool. Like I said previously, we did actually try and test it with our digital voltmeter, and we found that one of the wires, we got a 12-volt power, and then all the rest of them, including our ground, we were getting about 2 to 3 volts, showing that you can't really accurately measure it. You can't really accurately measure widebands with a scan tool. With a voltmeter.